All right, finishing up our systems of linear equations, we're actually going to talk about systems of linear inequalities today. And we've graphed single linear inequalities before, where we identified whether the line should be solid or dotted, which side we should shade on. So this is going to be combining two inequalities and dealing with the solution sets of both. So the first thing we want to think about, again, is what does it mean for a point to be a solution to a system of inequalities? This point, -6, -4, to be a solution has to fit both of the inequalities. So I'm going to plug -6, -4 in. -4 is the y. -6 is the x. And 2 times -6 is -12. -12 minus 5. I'm going to keep change. -4 is greater than -17. That is true. Plugging those same x and y values in. Four times -4 is -16. -3 times -6 is +18. So -16 plus 18 is 2, and that is less than or equal to 28. So that's also true. So that point, -6, -4, is a solution to the system because it fits both. All right, so new system of inequalities, new point, 3, -1 is our point, and we're going to test it the same way. So 2y plus 3x is greater than or equal to 7. 5y minus 2x is less than -11. We're going to plug 3, -1 in. And 2 times -1 is -2. 3 times 3 is 9. -2 plus 9 is 7. So that one is true. 5 times -1 is -5. 2 times 3 is 6. -11 is not less than -11. So that was false. So this point is not a solution. All right, so let's start getting into the graphing of these systems of linear inequalities. We're going to test 0, 0 first. So I'm going to plug 0, 0 into both these inequalities. Y is greater than -2x plus 3. Y is greater than or equal to 4/3 x minus 6. If we plug in 0, 0, zero times anything is 0. So 0 greater than 3 does not work. But on this side, 0 greater than or equal to -6 does work. All right, so we'll go back to that and we'll use that after we graph. But we're going to plot both of these inequalities on our grid here. So remember what we talked about in the last unit. When we have greater than or less than, the line is going to be a dashed line or a dotted line. And when it's greater than or equal to, less than or equal to, and it's a solid line. So y is greater than -2x plus 3. I'm going to start at 3. I'm going to go down 2 and 1 to the right. All right, and I like to leave my shading to the end just because I don't want to shade too much and then not be able to graph my second line. So let's graph the second inequality, y is greater than or equal to 4/3 x minus 6. I'm going to start down at -6. I'm going to go up 4 over 3. And this line is going to be a solid line because it's greater than or equal to. All right, so let's talk about shading for a second. So we talked about direction. When it's greater than, I'm going to think about shading up from the graph. So this one I'm going to think about shading up. Same thing with the red line, greater than or equal to, I'm going to think about shading up. If we go back up to the top here, 0, 0 was not in the solution set for the first inequality. And as you can see by the green graph and shading, that's true. 0, 0 doesn't show up. It's not in the shaded region. But in the second one, it is, and that shows up in the solution set as well. All right, so then the last thing when we have a system of inequalities, we're talking about the points that fit both. So that's not just in one shaded region, it's where they both are shaded. And we're going to label that section where it's double shaded with an S for our solution set. All right, so graph both inequalities, shade them, and figure out where they both are shaded, and that's our solution set. All right, so the last question is 3, 2 in the solution set. 3, 2 is right there in the double shaded region, so the answer would be yes. The point is in the double shaded region. All right, so for this next page is kind of a summary of what we've been talking about. So the procedure, the first thing, if we have a system of inequalities, we're going to rewrite the inequalities in slope-intercept form if we have to. So these two inequalities, 2x minus y is greater than -8, 2x plus 3x plus 2y is greater than or equal to 2. They're not ready to graph yet, so we have to do a little bit of rearranging. And remember, when you divide by a negative, the inequality has to flip. But y is less than 2x plus 8, that's ready to go. Y is greater than or equal to -3 over 2x plus 1. All right, so those, we're going to graph those. First inequality, y is less than 2x plus 8, dashed line shaded down. But the slope is 2, the y-intercept is 8. Add the second inequality. Solid line shaded up. The area where they're both shaded this dark shaded region, that's our solution set. That's where it makes the points are going to make both inequalities true. All right, so take a minute, solve these inequalities for y, graph them, see how they turn out, and then restart the video and check to see if your answer matches mine. Okay, so this is the solution set I have for this graph, and we're looking to see is 4, 3 a solution in the solution set. So if I go over to 4 and then 3, I'm looking at this point right here. All right, and that's a tricky point because it's at the point of intersection, but it's the point of intersection of two dashed lines. So when we have dashed lines, what that really is telling us is that the points on the line are not solutions, because those points are equal to where we have greater than or less than as our answers. So no, it says to justify. Now we can explain it. Both lines are dashed, so the points on the lines are not in the solution set. Justify means we also can show it. So if we were to take that original 4y minus x is greater than 8 and plug in that 0.43, 4 times 3 is 12, 12 minus 4 is 8, which is not greater than 8. And same thing for 2y plus 3x equals or less is less than 18. Six plus 12 is 18. And 18 is not less than 18. So you can explain it, you can show it, justify gives you a little bit of flexibility. But either way, it's not in the solution set because it really doesn't make either of them true. All right, so a little bit more practice. I want you to try to graph the inequalities on the next 2 pages. All right, so be careful with the dotted lines, shading. All right, but solve the system. And this first question asks us to state a point that's in the solution set. So don't forget, after you've identified the solution set, to state a point. But when you're done, restart the video and just check your answers. All right, so number 1, the solution set I got looks like this. Y is less than 2x plus 1 is going to be a dashed line. Y is greater than or equal to negative 1/3 x plus 4 is a solid line. And it says to state the coordinates of a point in the solution set. I picked 6, 6. So that any point that's inside of that double shaded region will do. It could land on the green line, but it can't land on the red line. So if you picked a point that's right on the red dash line, that will not work. And then number 2, we have one standard equation, y or inequality, y is less than or equal to 2x minus 6. And then one that's a little bit different, x is greater than 2. We've dealt with lines that are horizontal or vertical before, so x is greater than 2 is going to be a vertical line, and 2 is where it's going to cross the x-axis. It's going to be dotted. We're going to shade towards the right. So our double shaded region is over on the right side over here. And they ask us to write the coordinates of any point in the set. So any point you pick out that's in that double shaded region would work. I'm going to choose 8, 0.